Hello YouTube viewers, welcome to my channel Science to Technology. In today's show, Future Friday, we're gonna talk about Starlink beta results. So let's dive right into it. Now you have to understand I've already made the video when the beta was out, but now we have the data collection that has been done. So just an overview, what the heck we are talking about? We are talking about a LEO satellite based internet service provider. So basically LEO stands for low Earth orbit. We already have many service providers that utilizes geostationary satellite for internet and they have worldwide coverage. Only problem is because their satellite is so far away and because of inverse square law and the fact that light speed is limited, the latency is ludicrously high. I mean, best case scenario is 800 millisecond, and basically speed would be 5 or 4 and 5 mbps if you're lucky. So fundamentally that's not a modern internet, that's nowhere near good enough, so to say. So fundamentally this system wants to take care of that, and the selling point of SpaceX is once it's done, unless the government starts to block it, they should have 100% planet coverage. Basically it does not matter where the heck you are, they will give you coverage no matter what. Like, you have to just buy the equipment, the end, you don't have to think about it. And they are specifically focusing not on the metropolitan areas. Basically they're not focusing on Bangalore or New York or things of that nature. They're focusing on hard to reach places. That's their selling point. It's like, imagine like, let's say you bought a property next to a highway and that you want to live there, you want to work from home, and you could do that. You can fundamentally, let's say, do that, take care of all those things, or you want to retire there. It's just that there is no internet and you can't do that. And nowadays internet is not a luxury, it's a necessity. So fundamentally SpaceX is like, we're gonna take care of that, those hard to reach places. Basically think of it this way: let's say you are a forest you are studying forest life, you have to be in forest. How the heck you stay connected? SpaceX is like, we got you, man. So that's the whole point. And what they're gonna give you as a receiving station is a satellite dish, and you cannot use it on your mobile phone. Basically it's not a satellite mobile phone, so you have to have this dish. And to give you a context of size of this, it's more or less same as a satellite TV dish. However, this is much heavier and motorized. So because they want to give the equipment and have people mount themselves, rather than be like, okay, somebody is going to go there, find a lever, perfectly align it, they have to motorize it for that nature. So this is what we are talking about. Now location and speed, because the beta has been going on for enough time at this point in time that there is a good amount of statistical data point. So where we are talking about, we are talking about Canada United States border. So you take a line in that border region and draw with a marker, you will get that region. Now you might be like, okay, if satellites are covering around the planet, why the heck only this exact place has been selected? Because you have to meet two whole criteria. That one criteria is satellite coverage is needed, that's obvious, but you have to understand the fact, because Earth is rotating and Leo constellation, they are drifting. Technically from your point of view it will look like it's drifting, that you will always have a scenario where there is a lack of coverage. So fundamentally if they want to give you satellite internet, it must have 24/7 coverage. How they are achieving that is very simple. They have multiple satellite orbits with multiple satellites in that particular orbit. So they have 60 satellite in one orbit, and they want to extend it to as high as 800 satellites in one orbit. So that's the point. Once they have multiple satellites, they will take care of all the situation, but right now they are limited to 800 satellite, and they are still launching, basically 60 plus satellites every month. So they will take care of it, but as of now only this band has the scenario where satellite coverage is GG. So that's requirement number one. Now if you pay attention to any space kind of websites where they are tracking the system, you will find, hey, there are more than enough places where this criteria is met. The criteria number second is ground station has to be there. Right now these satellites are not acting as a constellation, they are acting as a relay station. It's just a relay in sky. So signal from your end goes to the satellite and it goes to ground station. Now ground station has to be in the same point of view. Basically it cannot go from satellite to satellite, it has to be in one satellite vision. Basically one satellite can see all the users and the ground station, otherwise it cannot route the data. So fundamentally these two things are the limiting factor. And as of now, even though satellite is moving ahead along much faster rate, the ground station is not. So fundamentally they are limited by ground station. And just few days ago, Canada gave them the approval. So ground station already being set up in Canada, and there are already people who are getting testing right now. Fundamentally right now there are more than a few connections in Canada that is going on, and testing is continuing at full speed. So fundamentally by the time 1 or 2 months will pass, hundreds of Canadians will be on the network, so to say. Now okay, that's the location and that's the limiting factor, that's why it's not everywhere. What about the speed? Like, okay, these people are paying a lot of money. You're talking about like hundreds of dollars, as in like $400 to $500 and $100 per month. That's a significant amount of money. What are you getting? Now be mindful, because it's a satellite system, because it's not a complete satellite constellation, the network speed is not very stable. However, SpaceX claimed that they're going to give you 100 Mbps, and they have delivered. Most people are getting more than that. However, because of the large variation, if I take the worst case scenario, like that is the worst case scenario, that's 50 Mbps. Now, you have to understand that 50 Mbps will sound very low to us Indians, simply because we have been kind of spoiled, and we are lucky because we have two fiber providers that are providing even in rural areas. Now, again, not every rural town has been taken care of, but enough is there that I'm living in a scenario where I can just pay for basically 1 Gbps connection if I want to, and I will pay less than what people are paying for Starlink. So 50 Mbps will sound very low to me, but all these people who got the connection and they have made their YouTube channel, they are fundamentally telling us, like, dude, I have satellite internet, I pay 10 times more and I get 10 times worse service. So there is no competition. For the people who are getting the system, they are like, shut up and take my money. It's mind-boggling. And old gentleman who was doing the testing, and he was not a very IT kind of guy. He's like, okay, let me figure it out, and he cursed in the video when he actually saw the speed. Is like, that's how bad his internet connection was. His internet is like, he had a good day if you got 5 Mbps, and you are like, tada, 80 Mbps, tada, 110 Mbps, oh, very bad internet, 50 Mbps. He was like, wow. So fundamentally, you have to understand this. At this point, constellation is not full, but still they are maintaining 50 Mbps, more than enough for more than enough task. That's like 4K basically streaming and all that jazz. You will not have an issue. However, because the coverage is still not absolute, there is still some downtimes. But again, it's not a dead downtime. It's like, okay, for that brief fluctuation where satellite is switching, you may have a scenario where your latency could go a bit higher. And what about upload speed? Now, upload on paper, it should be exactly the same as download, but that's not the case as of now, because again, they're trying to balance the bandwidth, but people are still getting 20 Mbps. Now, upload bandwidth is surprisingly difficult, even in fiber. Specifically, if your fiber service provider is YOLOing you, they're not going to give you good connection. I had to pay for 250 Mbps connection, simply because 10% of the download is the upload, and since I'm a full-time YouTuber, I need upload. So even to just get basically 25 Mbps, so I can understand that 20 Mbps, I'm good. I'm like, till few months ago, that was my speed. So 20 Mbps up, which should get better once they have figured out the laser and a lot of ground station. It should become better. And what about the ping? Now, ping is the main part. Many people will be absolutely comfortable with satellite internet if it's stable, which it is, and if its ping is high enough, basically where they can make a video call or phone call. Fundamentally, satellite internet till this point is around 800 to 1500 millisecond. This puppy, 40 millisecond. They are like, people are actually getting less than 50 millisecond reliably. What does that mean? That means you can practically game. Now, will this be the best gaming experience out there? No. Will this beat a proper dedicated fiber line? Hell no. But is it better than everything else? Is it better and more stable than a phone system? Absolutely. So 40 ms, it's very good. So fundamentally, ping is not an issue, upload is not an issue, download is not an issue, stability, you can say that it's not absolutely rock solid, but it's more than good enough. And the people who got this, all of them fundamentally are happy with the system, and most of them are like, just shut up and take my money. Now, let's understand the hardware, because SpaceX launched a system, not SpaceX, Starlink launched a bounty program on bugs. So basically, if you find a very crucial bug which have to be fixed, and you are the one who find it out and tell them, they will pay you some amount of money. So people started tearing down the antenna, fundamentally, taking apart. I have provided a video of a gentleman who did this down below. Now, this is a phase shift array technology. What does that mean? That simply means electronically you can aim the antenna. So your antenna would be like this, and then you can say the signal, go here or go here, go here, without physically moving anything. And the sole reason it has a motor drive is just to have that flat, basically relative to your altitude, it has to have a flat base. Only then it can manipulate the signal, because if you are tilted, the signal cannot go back. So fundamentally, that's why they have to have this drive system, but it's a phase shift array technology. Now, what does this mean? This simply means they are using very high frequency, as in very, very high 20-30 gigahertz kind of frequency. Benefit of that, antenna is smaller. Side effect of that, forget about range. It does not have range. So how the heck they are compensating for that? They have hundreds of those satellite, basically antennas on the system, and each of these antennas are triggered by what we call phase shift calculation. So because if you think of it in photons, it will not make too much sense, but think of it in wave sense, you will realize there is a what we call if you have waves, you can have what we call positive coloration and negative coloration. Basically you can cancel it out, how noise cancelling headphone does that, and you can reinforce it, basically amplify it. So doing that, basically triggering it properly, you can literally aim the signal. Now this technology is like very old, as in like 1970 1980 kind of technology, but it was used in like fighter jets for nose radar system, ICBM tracking systems. But nowadays it's cheap enough that even your Wi-Fi 6 router has this. 5G network is solely relying on this. So phase shift array is now cheap enough that it can be quote unquote common people kind of thing. So that's the whole point of this, and it has like multiple modules that are taking care of 4 antenna groups, and there are multiple of those groups that are taking care of the whole disk. So it's a surprisingly complicated system. To give you a context of that, this would be the biggest PCB that you will ever see in your life, in like normal consumer life. That is the biggest PCB. It's like huge. So that's the electric side. The mechanical side is also amazing. Now it is personally very amazing for me because I have seen many systems that have like what we call 2-axis tracking. So you can basically rotate in 2 axis. It has been used in solar system. Basically you want to track the sun, you need something like this. However, most of the time they have like one big motor that has rotates a caddy, and that caddy has a smaller motor that rotates the final product. It works, but it's very expensive. Now the reason why it's expensive is because you have 2 different parts you want to make. You always want to reduce your part count, and this is most amazing thing I have seen. Like I was like, whoa, how the heck they are doing this. Now I'm pretty sure somebody would have already figured it out. There may be already a product, but this is the first time I'm seeing this. This is what we call differential gear system, and they have 2 motors. Now here's the fun part, both of them are exactly the same. Basically the same factory that is going to make the left side, they're going to be like, okay, just double it, that will be the right side. Nothing complicated, nothing hoo-ha, that's it. It's just a geared, of course, because like it's a antenna is heavy, geared DC because it's simple, brushed motor because it's very simple and very torquey. So you have a lot of torque, you have a lot of gear down, so you get that system. And only 2 wire goes into the 2 motors, basically positive and negative. And those, because a brush motor, it can be very easy to switch the rotation direction. So that's how they are achieving it. They don't even have encoder feedback. If they used brushless DC motor, they had to have fancy controllers, 3 wires. They're like very simple. Amazing level of detail went into this. I'm like genuinely surprised. And it's like, and all the cable goes through the pipe, through the gearbox. It was like, wow. So I'm like, damn, I'm like, I saw this and I'm like, dude, I have to try to experiment with this in order to make it for a solar panel, because damn, it's really good. I would urge you to watch the video just for that. Gear system is like awesome. And then it also has inbuilt GPS. Now that GPS is not accessible to you. It's like there is no point of that. However, it's a very good data point for Starlink, so they can actually see, hey, we sent the dish there, is it receiving signal, is it not receiving signal, is there any magnetic interference, because Earth has a magnetic field and it can interact basically unfavorably, so to say. So you need to know exact GPS position of the exact antenna. That's why it has that. So fundamentally that GPS is not for you, but it is there for as a very critical data point. And then we are talking about heater. Now this is meant for higher altitudes, basically like, you know, places where it snows a lot. So it has a heater, and I'll explain about that more now. Now weather was the first question that I got in my videos. It's like, how is it in bad weather? Fundamentally it has an effect. So if you are thinking like, okay, I'm gonna have this system and no matter the weather my connection will be GG. No, it's not a fiber system, it's not isolated. It will have an adverse effect. However, it can handle a lot of situation, because you have to understand it. If you have 1 inch of snow on top of the dish will simply not work. I specified high frequency signal does not have that much penetration power, especially through thick dense material. So how do you take care of snow? Basically, you know, whole US has an issue with the snowfall, and Canada even more so. So how the heck you handle that? You make sure the first layer of ice does not fail. If you can take care of that, basically you have a dish and snow is falling. If the first layer does not pile up on it, you are golden. So how the heck they achieve that? Heater. That's why it has a heater, and power consumption can spike as high as 200 watts. But again, that's a spike power. Generally it remains less than 100 watt, and 120 and 30, that's just depending on your ice condensation. And people have already left it out in very serious snowstorm. You can see like there is a, like almost inch to foot of snowfall, and it has taken care of itself. Now again, if there is a very serious blizzard, it's like freaking snowing like there is no tomorrow. There is a limit to it, but fundamentally it's not like, oh, minus snowfall, I have to do anything. No, it's like it can take care of itself. So that's very good. Now wind speed is also a very critical thing, especially people who live in very high windy area, tornado prone area. The reality is it can handle mild winds, high speed winds, but not tornado class wind. It's like if it's serious and if you feel for it, just keep it inside. Like the engineer from I'm saying Starlink, they specified this, like if you feel like uncomfortable, just put it inside, because these are expensive puppies. So fundamentally, the reality is like all the data from all the people who have used it, from rainy scenarios, from snowfall scenarios to tornado kind of scenario, like high wind scenario, the reality is it will work in most scenarios. Now you can find yourself in edge case where it will not work, but most often, more often than not, this will work. You will not have a downtime because of this puppy. Now again, if it's a really bad weather, yes. So weather wise, it has an effect, but not too drastic. It's not like you're not dish TV. Like it will outlast a dish TV. Now ground station. Now this puppy is the main limiting factor at this point in time. You may be thinking, okay, those ground station, why not my country has the ground station? Because that's the part that government controls. Think of it this way, they can't stop, like let's say Indian government is like, I don't want Starlink in my country, they can't shoot down the satellite. So what can they do? They'll simply like, you shall not have ground station, the end the constellation will simply not work. And I specified right now satellite cannot do satellite to satellite communication, so that's the limiting factor. Now each nation has to have this is a legal kind of issue. So for example, let's say Nepal's government is like, you shall not provide this service. You cannot have that. Even if let's say from geopolitical point of view, you can literally have a ground station next to the border and can provide service. Again, that's the political aspect of it. And ground station is right now the limiting factor, simply because there is no satellite to satellite jump. Each satellite must have access to a ground station and access to the customer. That's why that exact band has been chosen, because that criteria can be met there. So ground station right now, SpaceX is trying to fulfill that, basically they want to paint a whole USA with the ground station. So they have made multiple system, which you can even spot on trailers. Basically, if they find out like this exact spot is awesome, they're like, just lay down the trailer right there. So that's the whole point, limiting factor. And it will not be a limiting factor after a while, once they have figured out a lot more satellites. B, they have laser communication satellite to satellite. Right now they do not have satellite to satellite. That's why this system is so very problematic. And rules and regulation is very critical aspect here, because even if SpaceX is like going YOLO, let's say they are releasing upwards of 120 satellite per month, which is bonkers speed, and they should cover like most of the planet, like good enough coverage on most of the planet by around 2021. At the end of 2021 they should have that. Is like, if they can't take care of the ground station, you will simply not have the system. So the regulation part is the issue. And you can see that how quickly, like once the Canadian government is like, okay, go ahead, it was like boom, beta project, people getting equipment, and everything is working. So fundamentally, regulation part is the main basically hurdle at this point in time. And even if they can bypass it, they will not bypass it, because fundamentally you do not want to piss off a government of a country. So, and that's the thing that they have to take care of at this point in time. So that leads to final problem, the final limiting factor, the laser. Now when they started, like if you see the oldest Starlink test, it was these two satellites and it had lasers, everything was awesome. But they realized very early on is that if they actually try to maximize the mass produce these puppies, they will simply not work. Fundamentally, they did not have the technology to mass produce it, cheaply enough, to mass produce it fast enough. So fundamentally, they would literally have rocket piled up. It's like, dude, the first rocket is still waiting for its 60 satellite. So that's the issue. So they are working on it right now. Whatever you have, all the satellites that are in the orbit, those are temporary satellites. Again, temporary at this point in time means around 4 or 5 years, but they are just as a foundation. Once they have taken care of the laser mass production part, that's their current issue, they will have satellite to satellite jump. Only in those sort of scenarios they can do ocean coverage. Right now they cannot do ocean coverage unless they have like multiple boats in certain locations where they have somehow connection. So that's their main limiting factor at this point in time. They have to take care of this laser aspect, and that's how they pitch the basically the whole constellation to everyone. Because the reality is, if you are always relying on ground station, you are just using a fancy system. You are just using satellite as a relay station. That's a waste of resources. So if they start to utilize laser moves faster in a basically vacuum than in a fiber. So fundamentally, you can physically beat the what we call latency. And for many scenarios, specifically stock market, if you tell a competitor is like, dude, I'm gonna reduce 5 ms of latency from your communication, they're like, dude, shut up and take my money. They will simply not care. They're like, dude, charge me million, I will make 10 billion at the end of the day. So fundamentally, even shaving a few little milliseconds is very important. laser should allow them a tangible advantage where there's like, specifically if they are doing point to point, imagine it this way, they are talking about in one satellite chain and the laser have to go through only one system. It's like tuk 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 tuk. It will like from two, basically let's say two persons are doing what we call video calling, you will have much lower latency than any other system possible, because it will like from your satellite to their satellite directly to them. Like that's fundamentally faster. They can achieve very low latency, which is flat out unachievable by any other system. So that's another aspect of it. That's when they will become a bonkers level competitor, where they can afford to charge much higher prices. Again, not for average consumer, but for like, stock market people, like, dude, you want very low latency, we're gonna give you best connection, we're gonna make sure you have multiple antennas and all that, but you have to pay the premium price. Because you can see that like even normal ISPs, they have different tiers. The tiers do not have like bonker speed or something, but it's like it will never go down. So they have to take care of that laser, and laser will allow them to cover the ocean, reduce the basically base station requirements. So right now their base station is like fulfill it everywhere. Then the base station will be like have two basically small base stations that are scattered around all over the world, and then have big base stations that will be like for Netflix, for basically anything that is not latency sensitive, go through the main base station, where it's like cheap electricity, cheap land prices, cheap internet prices. They are like SpaceX is gonna build their main headquarter, and to like make sure things that are latency sensitive, like let's say packets for video games, basically real-time systems, go through like whichever is nearest. So doing that, they can take care of multiple scenarios. So laser is very critical here, and point-to-point system is possible. However, once they achieve that, they have to create their own protocol. Right now they are running on IPv4. They will soon switch to IPv6, and then they have to create something their own. They are working on it right now. Fundamentally they are working on it, but it will take time, because again, the hardware is not ready yet. So this was my presentation on basically Starlink's beta result. Like we had the beta, what do we now know? So I hope you liked it, learn from it. In that case, please click the like button, share it amongst your friends. That will help me a lot. If you didn't like it, didn't enjoy it, I urge you to press dislike, press it twice to show me extra disappointment. Please leave a comment, because I try to reply to all of them. Subscribe, press the bell icon if you're free, and as always, thanks for watching.